then next up is Jeremy and Jez.
Hey everyone, I'm Jez and this is Jeremy. We're actually both called Jez, but we've decided to have two slightly different names. We are from FunFair, which is a London-based gaming technology company running on the blockchain. We founded the company about 2 years ago, but we kind of did a token sale a year ago, and we're now 45 people and growing rapidly. And the bottom picture is us having our first birthday party last week. So we're looking very happy. Yeah. So, thank you. So the problem we're trying to solve is making gaming, as in casino gaming, fair, because the biggest problem right now is that it is actually run on private servers in remote island locations, and the player doesn't know if they're being cheated or not. They don't know if the random numbers are being picked correctly. They don't know if the game outcomes are being calculated correctly, and they have no way of knowing if the game is fair. So we've built a technology platform that uses smart contracts and state channels to deliver that. One of the other big problems with casino gaming today is that players have to make a deposit into the casino, and the casino has custody of the player's funds, which is obviously not very fair. And then the player needs to ask for it back if they ever want to make a withdrawal. Another problem is that the random number generation today is all done in servers or oracles that have no visibility or transparency. So yet again, players just don't know if they're being cheated or not. So the state channel technology that we've built gives us some advantages and allows a safer place for players to play. It allows casino games to be operated in a safe way that is protective of the player, it protects the player's funds, and it ensures a safe and fair game. Also importantly, it makes the games play fast, which is what makes them fun. If the game was playing at blockchain speeds and you were waiting like a minute for an update, it would be excruciatingly painful. So the game has to play real time at internet speeds. So Jeremy's going to start talking about the technology and how that actually works. I'm going to just mention the random number generator uses entropy from both the player and the casino and delivers the random numbers in a real-time way using the state channels. And is it now a good point? Okay, we'll do demo first. The other thing that the state channels give us is keep the custody of the funds away from the casino and make sure that the funds are safe at all time. And ultimately, our goal is to bring trust into an industry that doesn't really have it. So we want players to feel safe and eventually to trust that the technology just works and that they will get a fair game, they will have fair odds, they will get paid immediately, and so on. Yeah, we're going to skip that one. All right, we're going to attempt a live demo. So I know this is extremely dangerous and may not work. So don't worry, I have a backup video if it doesn't work. But it's an internet problem, not a technology one. So here we've actually started. I'm going to turn the sound on now. Do we have sound? Well, yes, we do. Okay, so this is an example slot machine game that we've built. It's running on Ethereum with state channels. And you can see if I hit the spin button, we did not win. But I'll just keep playing it. But you can see that the game plays at the speed that the player wants to play it. We won a little. I'll click spin. So the player can literally press spin and keep playing the game. In fact, the game is currently on normal speed. I can actually tell it to go faster. And now reels run a bit faster. And so you can literally play this really, really fast. And yet, this is running, yay, wow, we did good. Okay, a profitable talk. So now I'm going to show you closing the state channel. Effectively, when you quit the game, this now will really test the internet, see if we've got it here. So I'm going to click cash out. And now what it's doing is asking the house if the game is over, and then if there's a mutual agreement, the channel will close. So we're going to try and open another channel in a minute. Now we're literally at the mercy of the blockchain and the internet and everything else. at this point.
So we'll just talk about something else for a minute.
Yeah, everyone talk amongst yourselves. Actually, something's going on today. Some stupid exchange in Hong Kong has decided to do an on-chain vote of random people. So the network is completely overloaded with people making votes. There we go.
Hey.
We've cashed out. Close the channel. Okay, has temporary unavailable. No. All
Okay,
right.
we've broken it. That's good.
We broke it. Okay. So what's
Hey, so that's a live demo. So one of the challenges, and I'll say this up front, is building a real consumer-facing application on top of Ethereum is hard. It's extremely hard. The technology, you know, it's that's going to work or not, I don't know. Is still relatively speaking in its infancy when it comes to sort of building consumer-grade applications. And one of the big challenges that we've faced is presenting a kind of clean user interface to people that actually makes sense without having to put a huge amount of crypto text all over the place. I don't actually know what's going to happen. The channel says it's open, Jez. Try spinning.
Try spinning?
Yeah.
Okay. Okay.
Okay. No, okay.
No.
Excellent.
All right, there's some internet connectivity problem
We're going
here.
to do this anyway.
All right, shall I run straight to the
No,
video?
okay, we can go to the video and we can show some of the other games. Fantastic. Excellent. So
Just to show you what is actually happening, if I click refresh now, you'll see that completely broken F gas station now as well, but a few minutes
that's
ago,
certainly
it was
not right,
more
is it?
than 100 gas just to do a transaction. Yeah, it's completely...
it may have lost your internet. That might be it.
Oh, okay, no internet.
Okay, well, never mind about that. So I just want to talk a little bit about state channels while Jez is sort of sorting that out. You know, this morning and this afternoon we've heard quite a lot about sort of payment channels and some sort of overview descriptions of state channels. So for me, when I first kind of discovered them sort of 15 probably months ago, so there's a really interesting sort of generalized approach to sort of optimizing and scaling sort of blockchain-based transactions in general. There are some very clever people in this room doing some very long-term thinking about how to build frameworks that can make truly general-purpose state channels, build application frameworks, build user interfaces, build payment channels and routing on top of that. And I'm really interested to see how those things progress. But our real objective at FunFair was just to build something that we can actually ship. And so we've come for an approach that's a much more kind of straightforward, sort of limited in as much as it's built with a specific end goal in sight, which is our actual product, but trying to keep it as general as possible in terms of the types of things that we can do, the sorts of games that we can implement on the channel. So we started with these this sort of what we call RNG games or fixed odds games. So a game like Blackjack is a deterministic game in the sense that the rules dictate what action happens. It's between you and the house. The house has a set of rules that they follow, and those rules can be clearly described in a smart contract, which is the kind of underpins the nature of what we're doing and what our channels can cope with. They can cope with any form of state machine. And just to recap, we had this in the last talk, a state machine being something that takes an existing state, and I call it an action on that state, but a transaction if you like, and produces a new state. So anything that you can encapsulate in an Ethereum smart contract that can do that is essentially what we provide in our state channel solution. The reason we slightly entertainingly call it fate channels is because what we've done is we've baked in a random number generation along that. So along with each state transition in the state channel, but both parties create a single unique piece of entropy that can be used for something. And so in the case of roulette, it would be, well, where's the ball landed? In the case of blackjack that we've just seen, every time the user presses a button, they'll get some cards. What were those cards? And then if they draw another card or if they hold, then you have more entropy that can determine the next cards that come out of the deck. So that's the kind of core feature of the channels that we built. We are primarily a sort of one-on-one channel at the moment, and we're obviously looking to extending that over time with a multi-sig lockup of funds at the start of the channel. The transactions take place entirely off-channel, and then the channel is mutually agreed and closed at the end. We'll carry on going, but at some point I'll talk about both the random numbers and dispute
I've got
resolution.
some more slides in a second.
Let you go.
Should we just skip the rest of the demo? Okay.
Try and get that running later.
There you go. Do you want to talk over that one, or shall I?
What have we done?
All right, I'll do the summary. So our state channel technology is node-based in that FunFair builds the technology and licenses it to casinos. Lots of hopefully one day, casinos. And they run a Geth node and the fake channel server, and there can be multiple instances of those. The random number generator, do you want to talk about how that works?
I mean, it's a concept that we've talked about before, and I think is reasonably well sort of understood now. It's an optimization of a commit reveal scheme. Clearly, you know, no one's really today, at least on Ethereum, has a on-chain random number system that works. You could use oracles. Obviously, you don't really want to use it to block hash, so we had to do something else. If two parties, a commit reveal scheme between two parties is could be expressed as I choose a random number and I hash it. Jez chooses a random number and he hashes it. We then swap the hashes that we've generated, and that's the commit phase. And we now both know that we have something. And then the reveal phase is to reveal the original number that we hashed. And if we then share those numbers, we can prove that the reveal is what we committed, and you can take those two numbers and put them together however you choose. We just stick them together and hash that to produce a random entropy. The optimization that we do is actually if you start with a random number and then you hash it and you hash it and you hash it for thousands of times, and you both do that, you can swap the last random number at the start of the channel, and then every time you need a random number, you just reveal progressively the ones back, and you don't have to do the commit phase because you've already done that. You can just hash the random number here to the next one to prove that it's in sequence. I've skipped through that pretty badly. I can explain that.
I love the way you were walking backwards as you were.
You have to visualize this as kind of this sequence of random numbers. But as far as I can tell, and I've talked about it extensively over the last year, that's as safe as it gets. And it's a collaborative scheme for providing deterministic but non-predictable randomness.
The key thing to those random numbers, I mean, compared to previous solutions where people are either using random beacons that are off-chain or they're using oracles that are off-chain, the problem with both of those are, firstly, that they're slower to access and not available in real time, and secondly, that they leave open attack surfaces. For instance, miners could collude with casinos or with players to have an advantage, or if it was a lottery, they could make sure they didn't lose, or it wouldn't cost them anything. So the random number generator that we built is completely real time, serves random numbers in real time to the game when they need them, and yet because it's only two parties, we can guarantee that it's random.
Cool. So on the generic states channel side, so I can talk a bit about how we've sort of made it a bit general purpose. So the channel itself is responsible for the looking after the funds and sort of locking them up at the start of the channel and for releasing them at the end. So we followed an approach whereby for peer-to-peer, the state transitions, you go from state 1 to state 2 to state 3. Each of those state transitions is signed by both parties sequentially, as in you should never sign state 4 if you've not got the signature from the other party on state 3. And at the end, we can agree on the last state. Now, another optimization is we're hoping that in general, not every state channel goes into dispute. So we have a separate case for the end of a channel. If we both agree, we sign a close message, co-sign a closed message, and you don't have to hold for any dispute period at that point if we've both agreed that the final state is what it is. But in order to progress the state, we have a collection of contracts that define the rules of the game. So in roulette, for example, let me give you an example. If I bet on red and the ball in European roulette and the ball lands on 3, then I should win. Right? That is a rule of the game. And so the kind of state transition is if the input state, well, there's no input state, doesn't it? The input state is my existing balance and the house's existing balance. And if my action is bet 100 on red and some randomness, then if the ball lands on 3, then my balance should be increased and the house's balance should be decreased, and that's the rolling state. So we have these sequence of contracts that apply the game rules to the state, and these in our model need to be encoded in Solidity, and key and counter to counterfactuals need to be placed on the blockchain. And there's two reasons that we do that. The first one is I actually quite like the fact that the rules of the game are on the chain, because if I'm going to play with a casino, I can look at the rules in advance and say, I'm playing this game, I know what's going to happen there. I can get my friend to verify them, or someone else can verify that these rules will be fair to me, rather than through just going up on the website and playing a casino and going, well, we'll set up a channel with this contract, but now I have to read the code. It feels like we can do something in advance. but also for our dispute resolution. So disputes, and I'm sure you'll hear all about this tomorrow, basically occur when there's a failure in the underlying protocol. So we have a protocol that says, I want to bet on this, and here's my random number. And Jez in the casino goes, okay, well, my random number's that. And we advance the state, and then he says, well, the ball landed on 4 and you lost. And I say, well, no, the ball landed on 3 and I won. So now we're in dispute. And the reason that that's a protocol violation is because we say that the state can only be advanced using this particular piece of code. And this particular piece of code is currently on the chain. Now, we don't run it on the chain. The important thing to hear is that it's an authoritative source of code that implements the rules of the game. And so what that means is that we can both independently take that code and run it locally on a local node or an EVM or however we want to do it. And that will give us the result of the game and, in the way that we've defined and which follows the protocol. So obviously we could both get it wrong, but in general, one of us might have got it wrong. And so at that point, we can go to the chain to resolve this. And the way we do that in the chain is by posting the previous state transition and assign that, which is co-signed, and my action on that state, which is signed by me, and an assertion that it moves the state to the next state. And the game and the on-chain Ethereum network can verify that that state transition is correct using the contract, which is on-chain, but only at the point of dispute resolution. There's a second step to that, which Tom Close is going to talk about tomorrow, whereby if you repeat that process back the other way, and then the other party does the same thing, but signs, this is complicated, but posts their subsequent state transition on the chain, which can be verified, and signs it, you have the ability to get a dispute resolution back off chain. I'll let him talk about this tomorrow because it's really, really interesting. But it means that you can take a dispute in a channel, go to the chain to arbitrate it, and get back off the chain without actually closing the channel, and that can carry on going. That's really
just to highlight some of the differences between what we're doing and what some other people are doing. So the smart contracts are on-chain in advance. That also cuts the cost of dispute resolution because you're not having to publish any contracts to cause a dispute, which today the gas cost is 100 or more gwei, and that's just insane. If you were to try and initiate a dispute, it might cost you $100 or hundreds of dollars, and you might be only disputing a $5 bet or something. So you need to keep the cost of disputes low, and so one of the ways we do that is by keeping the smart contracts fully created on-chain. But also the auditors and regulators that try and ensure fair play would like to see those contracts, and they want to audit them, and technical people will want to audit those contracts too. So having them fully available, pre-published, guaranteed this is what you're going to run when you run the games, they're already on the chain, is a much safer environment. Okay. So are we going to talk through that, or should we skip that? Oh, we'll skip that.
Okay, I've kind of talked about that anyway, so that's fine.
Dispute resolution.
Yeah, so the only other, so in terms of dispute resolution, we've and again it's been talked about before, there are only really two things that can go wrong. So the first one is that if you post a stale state, so anyone posting a stale state, given that we co-sign all of the state transitions every time, anyone posting a stale state is definitely doing something wrong. And we just take a very heavy-handed approach here. If you post a stale state as a dispute, anyone, me, or whoever you've shared your state with, can post any co-signed later state, and that's demonstrably wrong, and you're penalised. Everything else we treat as a violation as a failure to advance the protocol. So if we treat you trying to cheat as the same as you going away or slamming down your laptop in disgust because you've lost, and that just it simplifies the whole process, and then that institutes a dispute, all of which are categorized by the word timeout, as in I have not been able to get the other party to react in a meaningful way to advance the state. And I kind of described a little bit about how that works.
Well, one of the biggest things we've been doing for the last year is actually making this usable for the mass market. It's one thing creating state channels and having the technology work. It's another thing to actually build the user interfaces, and the user experience is the most important thing. And so we spend a lot of time doing that, and we've still got a lot more work
If
to
you're
do.
building a casino that's supposedly provably fair, you should probably never see a dialogue saying, by the way, we've detected that the casino is trying to cheat. So we need to find some language that really kind of that explains this in a useful way to people.
So other differences that our state channel implementation has versus others, we are doing short-lived channels that are open during the game session. So when you sit down to play a game, your deposit and the random numbers are all committed to the chain. And you play the game. You can play the game for multiple hands, hundreds, thousands of games, however long you want to play. But when you quit the game or when you're done, the channel closes and it sends the funds to the user and the casino appropriately. The reason that we're doing short-lived state channels, well, we've got lots of reasons. Firstly, that we're not convinced yet, until there's a lot of use cases out there for people to leave money in channels, we're not convinced people want to leave money in channels for long periods of time. And I think it's a poor user experience until there are the wallets built to do that, and enough applications that justify people leaving funds in channels. So as the funds are only locked in the channel while you're playing the game, and you quit the game and they're back.
And I think one point in that one, because it's a bi-directional channel, you have to be active when you're in the channel. You can't leave it open, because if you've got a situation where you go away for a week and the other party can knows you're on holiday and post a stale transaction, it means you have to leave these timeouts for as longer than you'd like. But we're really, at the moment, working on that principle of keeping short-lived channels. I think there's a lot more work needs to be done before I'm happy. It's going to happen, but I'd be happy to leave these things open for weeks.
So another area of difference is that we're a single hop architecture. The game that the player is actually playing directly with the casino, and so we can guarantee availability because they're both online, and that's the best use case. Actually, gaming is absolutely the perfect use case for state channels, because you've got two parties that are going to do a lot of transactions with each other in a short space of time. That it's completely different than a network model where a random person is trying to send funds or something to another random person, and it has to calculate a route, and it has to have enough funds and liquidity on the way. I mean, that's a difficult challenge, and it's also relying on somewhat of a network effect before that's viable, whereas a single hop architecture is guaranteed to work tomorrow, and that's how we're able to build a complete platform for gaming that will run tomorrow or whenever we launch it.
Mm-hmm. Yeah.
So in terms of games development, this is an open platform in that outside companies can build games and run them on this platform. Although we built the first bunch of games, there are actually game developers right now that are not FunFair that are building games for this platform. A game is in two parts. It's the graphics user interface. It's the front end, the thing that looks pretty and that interacts with the user, and it is also the smart contract that computes all the backends. And the smart contract, there's a different one for each game. So there's a different one for blackjack, a different one for roulette, and so on. We whitelist the games for fairness to make sure that they're fair, and we thoroughly test them. So we're about to wrap up, but I'll skip through. Should we leave time for questions, or should we just... So in terms of scaling, because it's a node-based architecture and because each casino will run a separate node, the scaling is multiplied by the number of nodes that are running. So, and each individual node can cope with hopefully hundreds of players doing potentially thousands of transactions. Thank you very much.
Thank you.
So is there any questions? Yep. Okay. I'll jump down here first because Eric hasn't actually asked a question yet.
Hey, really fun presentation. I'm just wondering, how limiting or not limiting have you found the computational and space limits in terms of kind of if you need to be able to handle dispute in a block, then
Yeah.
yeah.
So at the moment, basically okay. I mean, clearly it does limit what you can do. We've done a lot of optimization in those smart contracts and looked at different types of approaches. It's not what you would traditionally do for an online casino. Some of these slot machines, I was looking at one, and I was actually doing the maths to work out how much it would cost to get 10 megs of data on the blockchain, and the answer was not more than you'd like, right? Because a lot of this stuff is table lookups. So you can do a lot of interesting work there by just optimizing the thinking around what you're doing. I would say, and we plan to get this down, that it's going to be in the hundreds of thousands, but it's not in the millions for anything reasonable, and certainly possibly less than that. I mean, it gives me the opportunity to talk about another little optimization. Is that haven't we? Okay, all right. Well, okay. I'll take another question if it comes up. I'll bring another optimization.
Okay, I'll go to other people first because they're new.
There you go. Hi, Valerian from PopChest. We're building a decentralized video platform. The easiest way to think about it is YouTube on the blockchain. We're using the machinima state channels library to do that. And as you can imagine from the YouTube part of it, it's a very consumer-facing applications. Once you get people into the channels, everything is great. Can you speak to the challenges of getting everyday normal people who aren't into blockchain getting that initial hop into the state channel?
Well, I can say that we're 6 months into that process, and we certainly haven't finished it yet. I think it remains it's not complete yet. I don't think someone will point me at some website I've not seen, but no one has yet done it. It's an ongoing research project. It's going to take a lot of work from individuals and from the community as a whole. It's going to take a lot of time for, as crypto in general gets more mass market awareness and people understand what a wallet is and where people's funds are and why you can't open a state channel directly from an exchange. Anyway, lots and lots of work to do, and we're just plowing on with it as fast as we can. Thank you.
Sorry, quick question. First, I saw the very slick UI. So, how's a random numbers, like you say, commit and reveal happen when you play the game on the website? And second, can I get the intermediate states, like when signature, so I can keep it for my history reference or for the dispute resolution later? Yeah.
So I think the second question was about how can you see what's going on, and I think the first question might have been the same thing. Essentially, can you see? So actually, literally, last week I've been looking at the visualization of the channels and how to prove what's going on, and we've got quite a deep customer-facing, hopefully, sort of flow of you can drill into each of the transactions. Here is your list of each of your hands, and we say it's fair. No, if you click into that, these are all of the actions. The RNG was fair, the game logic was processed correctly, the signatures were correct. You drill into that, you actually get to see the individual data. If you really want to go down that far, and you can see the previous state and the signatures on it, you can see my RNG, his RNG, you can follow the RNG progression, you can verify that the hashes are correct, that the two numbers hashed produced the RNG, that the mapping produced the fact that the ball was on 3, and given that the ball was on 3, that I won. And then if you really want to, you can get the raw JSON, which has been co-signed, and you can actually call the smart contract and verify it yourself. So there's a lot of work to do on that, but we are going to bring all that out to the fore.
Yes, my question will be where the entropy of the client, so the gamer, and the entropy of the back end, so the casino, actually comes from.
Yeah, I mean, that's a reasonable question, to be totally honest. I mean, both. So they're short-lived entropies, right? So the only real issue, there are two issues there. One, if you can hack the client, which is bad anyway, and then the other one is if whatever you use is in any way predictable. Now, I mean, there are crypto libraries in JavaScript, in Chrome, that provide some level of short-term entropy, and I'm actually literally doing an analysis of that myself to really understand what it is. Well, it does matter if it's predictable, right? So if the server can predict, or the casino can predict the client's one, this is a bad thing. And on the server side, well, we're actually writing this in .NET and Windows, and the Microsoft Cryptographic API has been good enough for me for the last 10 years in my other businesses. So hopefully it will be for this.
Yeah, just one more question. Maybe it's not technical and not related to blockchain, but I'm just curious.
I do the non-technical questions. That's fine.
I'm just curious, what's the reason for casinos to go into something where they cannot fool the user?
Well, I mean, you can answer.
What's the reason casinos?
Well, why would casinos bother to set?
Yeah, you mean why would casinos want to have a fair casino? Well, obviously, some casinos out there don't want to be fair and just want to milk their users and then maybe exit scam or something. But most casinos want to be honest. Most casinos want more business, and they'll get more business if they're seen as fair. So, and the regulators all want casinos to be fair, and so the casinos look better if they are fair. So we think there will be some, and hopefully lots, of casinos that do want to be fair and prove it. Thank you so much, everyone.
Awesome. Yep. Thank you, guys. Yep. Awesome.